transfer function of an electrical network, another network. Okay, this is an electrical circuit which is given. The question will be like this: obtain the transfer function of an electrical network shown in the figure. So here it is given as the source is E of V and the voltage across it is V1. Okay, and here is the resistance named as R1, capacitance is C1, and another resistance is R2, and one more capacitance is C2. What is the output voltage? This voltage across it is named as V2 of V. So we have to find what? Transfer function. So to find transfer function, what is the formula? What is the transfer function formula? Laplace transform of divided by Laplace transform of V2. Here what is the output? V2. So it is Laplace transform of, right? So V2 of S divided by what is the input? E of V. So it is Laplace transform is known as E of S. So we have to find this step. Okay. Initially we have to know the node, that is here one node 1 and another node 2. So what I am going to do? I am going to apply the KCL here. Okay. So applying KCL law for what? The node 1. Okay. For applying KCL law, you have to do what? Here the voltage, the source is what is in terms of voltage. What you have to do to apply KCL law? You have to do the source transformation, which we are studying in circuit theory, electrical circuit analysis. We have to study source transformation. If we transform this voltage source in the current source, means the resistance which is connected in series will become to the parallel. You remember that. So now I am converting this as source as I of V. This is said to be what? Source transformation. The voltage source is transformed into current source. Okay, and now who's there? The resistance will come connected to in parallel. Resistance R1. Okay, this is the source transformation. Now it is transfer. So the node here is what? Capacitance. Okay, so we have to write what? Differential equation by applying KCL for the first node. Who and all connected to the first node? To the first node there is a resistance R1, capacitance C1. Both are individual to the first node. Who is in common to both and particular node to resistance R2. So we have to write the voltage. Why we have converted this source voltage to source current? We will be writing in terms of current. That is, we will be writing as I is equal to what? V by R. Okay. So here our unit is what? I of V. So if it is our voltage here, it is E of V by R. Our E of V has how many based on the node, how it is termed as V1 in the first node, and for second node it is V2. So according to this we have to write the equation. Okay, so consider this first node. Okay, consider the first node. When you consider the first node, what are how will you be writing the equation? First V1 by R1. That is the voltage across the resistance is V1. So it will be like this, right? Here what is the voltage? Across the resistance voltage is V1. Okay, so the parallel electric capacitance will come to the series. I will remember all this thing. Okay, so now this capacitance, how will you write the capacitance? This is the voltage source, that is C1. Straight up I told you this dV1 by dt. Clear? Next, who is there? Resistance R2, which is common to both the node 1 and as well as 2. Now we are applying for the node 1. So it will be like V1 I am considering. Who will have the minus V2. That is this V by R, right? So V1 minus V2 by R2. Because we have considered as current source. So it is V by R. V1 minus V2 by R. The resistance across it is R2. So it is R2 is equal to here for the first node who comes. There is an input over here, right? So it should be termed as it is E of V. So E E of t means how will we writing it?
E of s.
E of before taking
Before
the Laplace transform. Now the equation is before taking the Laplace transform. Now after what we have to do now? We have to take a Laplace transform. Okay. So Laplace transform for the above equation. What happens? V1 will be the V1 of s by R1 plus C1 into S into V1 of s plus V1 of s minus V2 of s by R2 is equal to capital E of s. Okay, and now next, what you have to do? Just split this. So R2 into as two terms you have to split it. Okay, that is V1 of s by R1 plus C1 is into V1 of s plus V1 of s by R2 minus V2 of s divided by R2 is equal to what? E of s. Okay, and now bring on that V1 of s take common outside. The first three times, right? So you take common outside. Okay, what will become?
V1 of s.
1
by R1.
1 by R plus, sorry, 1 by R1 plus
C1
into S plus
1 by R.
1 by R2. Okay. Here is a term E of s, right? So if it is E means the voltage of this is what? V1. So the E of s can be replaced by what? V1 of s. So what we are going to do? Here, this term is minus. Correct? So take this to the right hand side. So what happens?
Equal
It will be for E of s plus
V1
of s
plus
plus
V2 of
V2 of s by
R2.
R2. Clear? And now that is V1 of s into now this cross multiply all this time and bring the overall as R1 R2. So cross multiply what is missing here? R2. So R2 plus here
C1 plus R1.
C1 R1 R2 yes. Correct? Next here it is R1 is equal to what?
V1
of s plus V2 of s by R2. So listen, everything we are doing it in current source. Okay, for current source we are giving I of t. I of t is what? E of t by R. So for the current source I of t means E of t by what is the resistance R? R1 is near to it, right? So how we have to replace this E of t by R1. So after taking the resistance what will become? E of s by R1. Like this E of s by R1. Okay, and here we will also E of s by R1. Since we want to find the transfer function, that is V2 of s divided by E of s. Okay, and now here what happens here? What is left in the left hand side? What it is here? It is minus V of s by R2 is equal to what? E of s by R1. Okay, so now take this as equation number 1. Okay, let this be as equation number 1. Okay, now we have to apply KCL for node 2. Okay, so look at your node and then we see equation applying KCL to the node 2. Look at the circuit diagram and tell me how will we write it out. The node 2 which is in touch with the node 2 that is connected R2 as well as C2, right? The output V2 of T we don't know that. So it is equated to 0 initial condition. So it is equated to 0. Okay. So what we have to do? Let us
V1
for R2 what it is?
V2
minus V1. Since it is node 2, we will be having the V2 and minus V1 divided by R2 plus C2 dV2
by
divided by dV2 by dt is equal to what? 0. Okay, from here, what we have to do? We have to take the Laplace transform with 0 initial condition. 0
initial
condition. Okay, and now what happens? It will become
V2 of plus
V2 of us shall I write separately?
R2
V2 of us by
R2
minus
minus
V1
V1
of us by
R2
This is
plus
plus
C2
C2 into
yes
S into
V2 of
V2 of us that is equal to
equal
what?
to
0. From this equation, what I have to find out? V1
V1
of us. Okay. So if I found V1 of us, I have to substitute over the first equation so that I can find the Laplace transform V2 of us by V of us. So from this equation, I have to find the V1 of us, right? So let this term be allowed here. That is what? Minus V1 of us by R2. Okay, is equal to what? If I take these two terms on the right hand side as well as this term to the right hand side, what happens? It will go into the minus. So shall I take the minus common outside? That is minus of V2 of us divided by what? R2. Okay, and both the terms are coming to the right hand side, means it is minus. So I am taking common outside. It is minus of V2 of us by R2. Here again plus. It is C2 less V2 of us. So, okay, that is equal to no. I have taken it outside. That's it. Okay, now here I am going to cancel the minus minus. What I have to provide from here?
V1 of plus
V1 of this. Shall I take the V2 of this common over here? That is
V2 of
S into
1 by
okay, 1 by R2 plus
C2 of us.
Yes. So, shall I take this denominator of R2 over here? So, what happens? Into R2. Clear? So, the next step, see, if this like V1 of us is equal to
V2 of
V1 of us is equal to V2 of us into, should I multiply this R2 over to the term inside? So, that is
R2
what will become R2 by
R2
R2
plus
plus
C2 of
C2
R2
R2 yes. Here it both will get cancelled. So what is the V1 of us then?
V2 of us
V2 of us
1 plus
1 plus
C2
C2
R2
R2 yes. So take this as equation number 3. Now substitute 3 in what? In the first equation. Okay, substitute the third equation in the first equation. So now, what will happen? In this place, we will substitute this term.
V2 of
That is V2 of S into 1 plus C2 R2 S. Okay.
1 by
Into what?
1 by
So,
R2
here we can do a calculation. We have done a calculation, right? That is V1 into S. We have cross multiplied
R2
that is R2 plus
C1
C1
R1
R2
yes
S
plus
plus
R1
R1 divided by
R1
R2 is equal to what?
V2
Sorry, minus
V2
V2
of
of
us
S by
R2
R2 is equal to
E of us by
V of S by R1. Okay, and now the substitute. That is here. V1 of us we have substituted. Now substitute the other term. That is
R2 plus C1
R1 R2 into S
plus
R1
divided
the whole divided by R1 R2 minus
V2 of S
by
R2
R2
minus
equal
equal to E of S by
E of S by R1. Okay, now solve that equation. Okay, now after solving it, we will get the answer. So now we can solve it. So this is a term as well as this is a term. Okay, two terms. We both of them is common. V2 of us. So let us take the first V of us as common. Okay, then what will be inside?
1 plus C
1 plus this 2 in both in multiplication. Right? So write the numerator commonly.
yes
So 1 plus
C2
R2 S
yes
into
R1
R2
R2 plus
plus
C1
C1
R1
R2 S plus
R1
R1. Okay.
whole divided
Plus the whole term divided by
R1
R1 R2. Okay. minus 1 by R2 because I have taken the V2 of us I have taken the common outside. So it will be like minus 1 by R2. Okay, now is equal to what? E of x by R1. So now shall I cross multiply this two times?
Yes.
This R2 and this term over here. Okay, then it will become like E of x into. If I cross multiply it, what happens? The R2 will come to the numerator, right? So the R1 will get cancelled. So what will remain? 1 plus into R2s into R2 plus C1 R1 R2 s plus R1. Here comes the R2. In the denominator there is an R2. This both will get cancelled. Okay. Then who will remain then? The term remaining will be divided by R1. Likewise, I will cross multiply it, right?
R2 cancel.
What happens here? R1 cancel, right? So who comes here?
R1
minus R1. Okay, and now
equal to
that is equal to what?
E of
x by
R1.
R1. Okay, now shall I equate these two terms? Denominator has a R1. Denominator is also R1.
Cancel.
Then separated transfer function.
Yes.
So you have to count it, right? So listen, while we have cross multiplied it, okay, R will come to the numerator and we will just cancel it. Same as what we have to do, we have to multiply this both, right?
Yes.
So that is R1, R2 and R2 will become R2 square, right? R1 is there in the term. So R2 and R2 will become R2 square. In that R2 square, we have cancelled one R2. So what will remain?
R2.
Another R2. Should I understand? We have after cross multiplying it, the numerator there is an R1 times A. It will be like this. Okay, and here the term is R1, R2. Correct? So after cross multiplying, what happens? These two things will get multiplied. So here is R2 and one R2 will get cancelled. Here what happens? R1 R2 that will get cancelled. So here minus R1 will follow remains. Okay. So after we do the increments, what is the denominator?
R1.
In the denominator, R1 is being cancelled, right? So this remains R1 is cancelled with this here to the right hand side. Okay. So the term remaining is in that R2 square, the one term R2 remains. Okay. And now what is the V2 by V of this then?
V2 by V of.
See, first initially find out the E of us by V2. If we take this right hand side, what will remain in the left hand side?
1 plus C2 R2
C2 R2s
R2 plus
into, shall I write like this? R1 plus R2 plus C1 R1 R2s
plus
minus R1. Shall I write like this? I will just interchange these two. R1 enough for doing R1 plus R2 and the third one plus this. Okay. Overall minus cancel R1. Denominator what is this? R2. This is the left hand side. What will be the right hand side then? E of us and V2 of us will come to the denominator. But what is our transfer function? V2 of us by E of us. So what we have to do? We have to just take the reciprocal of both left hand side as well as right hand side. So what happens? V2 of us will be by E of us will become R2 divided by
C1
1 plus C2 R2s into
R1
plus R2 plus
C1
R1 R2s minus R1. This is our transfer function which we will do find. That's all. Okay. So like the last exam which we have solved for the electrical network, we have to try these things. Okay. So for the first circuit, so the input EI. So after doing the source transformation, you will be taking the node. You have to see how many nodes are there. Based on that, you have to form the equation. After solving the equation, you have to determine the transfer function. That is E naught plus by EAFS for the first step. Right here after converting the source, what you have to determine the load. Okay, first. Then after solving the equation, you have to go to the transfer function. Okay, that is E naught plus by EAFS. Similarly, for the third. Okay, after doing the source transformation, you have to solve these things. Okay, and next topic is for the electromechanical system. That is, we have to determine the transfer function as well as the electromechanical system. Mechanical system, we have seen two systems. One is mechanical translation as well as mechanical rotation. Right. So first, electrical analog is the mechanical translation system. So in mechanical translation system, what is the input here? Force. What is the output here? Displacement x. Okay. So how we transform it? Here there is two analogs. One is force to voltage transformation analogous. Another one is force to current transformation. So that is the force voltage analogy, and one more analog is force current analogy. We just have to know what happens when this mechanical system analogy is converted into electrical system. Okay, this is the conversion. If these things you have to, if we know this means you can easily form the diagram representation into the equation. Okay, as a mechanical translation system for solving the problem, there is a diagram, right? There is mass is m, a dashboard b, which is coming to both m1 and m2. It will be forming a differential equation, right? Same method you will be writing the differential equation over here. But what you have to do is you have to convert them to the electrical system. In place of mass, so like in place of force F. Here in mechanical transmission system, the input is F of T, right? So when you are converting into the force voltage analog, force to voltage electrical analogy, it should be written as voltage V. Okay, and the velocity V, which is in the mechanical transmission system, will be known as current I, and the mass M will be written in electrical system as inductance L. In terms of force to voltage, okay, F V analogy, F to V, velocity V to current I, mass M to inductance L. This V is a dashpot, which is a friction coefficient, piston. Okay, the friction coefficient is V, will be written as resistance R, and the displacement X will be written as charge Q, and the stiffness constant is spring K. That will be written as the reciprocal of capacitance, that will be as 1 by C. The reciprocal of capacitance will be written as 1 by C. Okay, and like this, in short, I like it. For the same. Okay, for the same, in short, we can say this F of T should be written as voltage P of T. And T is here, the velocity. What is the velocity which is termed as mechanical system is for every dashpot we have written dx by dt. The dx by dt term is said to be velocity. So wherever the dx by dt terms come, we have to replace it with what? Current. Okay, in the conversion. Okay, likewise the spring K is replaced with the reciprocal of capacitance 1 by C. And likewise dashpot, that is friction coefficient V should be replaced by the resistance R, and the mass M should be written as inductance L. Okay, these things you have to know. Likewise, for the force to current analogy, we have to solve it. The question will be like this: determine the transfer function, or else determine the electrical network. Whether it will not be asked as transfer function, it will be asked as determine the draw the electrical network for the mechanical transmission system. It will be like draw the electrical network or draw the circuit diagram for electrical network for a mechanical transmission system, and the diagram will be given to you like mass, dashboard, spring. As the first problem which we have discussed before, the mechanical transmission system, we will be writing the differential equation. After writing the equation, you have to convert the source. After the conversion, you will be writing the electrical network diagram. Okay, like you will get clear after I solving one problem. Okay, first you know this diagram. So likewise here force current analogy means mechanical system. Force is termed as current I, F to I. Okay, and velocity will be here as voltage V to V. Okay, and then mass is written as capacitance C, which will term as flux phi and stiffness constant K will be turned to reciprocal of inductance that is alternated. Okay, in short, this we can force voltage we have made it short, right? Like this we made this as short also. So it will be easy for you.